Hey there, students! Today, I'm going to walk you through the preparation of a calibration curve, specifically for blood glucose. Calibration curves are essential tools in analytical chemistry. They help us determine the concentration of an unknown sample by plotting the instrument's response against known standards. Let's dive in. First, let's talk about the reagents you'll need. You'll need a stock standard solution. To prepare this, dissolve 360 milligrams of pure dried analytical grade glucose powder in 100 milliliters of a saturated sodium benzoate solution. Sodium benzoate is a preservative, but you can skip it if you're using the glucose solution immediately. Now for the working standards. You'll dilute the stock standard according to table 5.3. Here's a quick summary. Tube 1, 0 mg/dl glucose, 1.0 milliliters isotonic sodium chloride solution. Tube 2, 90 mg/dl glucose, 0.25 milliliters stock standard, 0.75 milliliters isotonic sodium chloride solution. Tube 3, 180 mg/dl glucose, 0.5 milliliters stock standard, 0.5 milliliters isotonic sodium chloride solution. Tube 4, 270 mg/dl glucose, 0.75 milliliters stock standard, 0.25 milliliters isotonic sodium chloride solution. Tube 5, 360 mg/dl glucose, 1.0 milliliters stock standard, 0 milliliters isotonic sodium chloride solution. Let's move on to the procedure. Set up 5 test tubes in a rack and proceed as shown in table 5.3. Process the entire batch according to your method sheet. Take the absorbance readings up to 3 decimal points and plot each absorbance reading against its corresponding concentration on linear graph paper. Join all the points on the graph. They should form a straight line. If the line starts deviating at high concentrations, determine the limit of linearity from the point of deviation. The relationship between absorbance and concentration holds true up to this limit. From this curve, you can create a table showing the concentration of glucose against each absorbance unit. Alternatively, you can calculate the factor for each analyte by dividing the known concentration of the standard by its absorbance. Factor F equals the concentration of the standard divided by its absorbance. You can then find the unknown concentration by multiplying this factor with the absorbance of the unknown sample. Finally, remember that some procedures require a fresh calibration curve with each run of tests. In other cases, you can periodically check the curve by running controls. Always check or prepare a new calibration curve if you change pipettes, reagents, standards, instruments, or technicians. And that's it. You've mastered the preparation of a calibration curve for blood glucose. Keep practicing, and soon this procedure will be second nature. Thanks for watching and happy experimenting.